Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to talk about how to graph exponential functions as well as transformations such as shifts, reflections, and stretching or shrinking. So the first thing I want to do is I want to show you what an exponential function looks like. Exponential functions are famous because they look like this. They never cross the x-axis, or at least if you want to cross the x-axis, you need a transformation of some sort. And these functions are also famous because they have a horizontal asymptote at the line y equals 0, which means the left part right here will approach but never touch my blue dotted line, the asymptote. These functions are always in the form y equals a times b to the x power. It doesn't have to be written in this form necessarily, but I call this the parent function, because all the transformations that we're going to do today are based on this function. So for instance, if I have the function y equals 2 times 3 to the x, a is 2 and b is 3. And the reason why that's important is because when we want to graph these functions, there's a few points I will always know about. For instance, I will always know that when x is 0, y is the a value, whatever the a value is. We also know that if x is ever 1, then the y value is a times b. And these 2 points I would absolutely recommend memorizing because it's the same thing every time. And then any other point you want to plug in, for instance 2, it's going to be a times b squared. And if you want to plug in 3, it's going to be a times b cubed. And you kind of see how this pattern repeats. But really we only need these first 2 points, and then the rest of it we can just graph based on these 2 points. And now I need to talk about transformations, because there's 3 kinds of transformations we can have here. The first kind is the shift. The shift is the easiest to do. So for instance, if I have the function y equals x minus 2 to the x minus 3 plus 5, then the shift has to do with the minus 3 and the plus 5. The minus 3 is a shift 3 to the right. And why is it the right? Because it's supposed to be minus 3. Why isn't it left 3? Because for the x shift, it's always the opposite of what you expect. And then for the y shift, this plus 5, that is going to be a shift up 5. And so the y shift is much easier because you don't have to flip it. It's just plus 5, so it's up 5. We'll be doing a bunch more of these examples later today. Next, scaling, also known as stretching or shrinking. And this would look something like this. You can either say, based on that example I had last time with 2 to the x, there's 2 ways you can scale it. The first thing you can do is you can say like times 5 out in front, and that would be stretching it by a factor of 5. Or you could also put the number next to the x, like you could have 5x, or maybe you want to do 1/5 x, and that's also going to stretch or shrink it. Putting it next to the x is a little more advanced, so I'm not going to cover it in this video, but I will talk about putting the 5 in front, because that's the same thing as the a term we were just talking about a minute ago. And then the last thing you can do is you can have a reflection. And for the reflections, you can either have an x-axis reflection, which would look like this. If this is the original graph, then the x-axis reflection looks like this, and I would memorize that. Or if you have the y-axis reflection, that would look like this. And again, I would memorize these reflections. Now, how do I know if I have an x-axis reflection or a y-axis reflection? I'll tell you. X-axis reflections will always look like this. The negative sign is out in the very front. And the y-axis reflections will always appear next to the x. So once again, it's backwards. The x-axis reflection is when the negative sign is not next to the x, and the y-axis reflection is when the negative sign is next to the x. So yes, that is backwards. And those are the 3 transformations that we need to know about. Finally, the order of the transformations. Number 1, do your reflection first. Number 2, do your scaling. And then number 3, always do your shifts last. And this is the order we're going to follow. So without further ado, let's start looking at some practice questions. The first one I have here is the function y equals 2 to the negative x plus 3. And for this problem, I want you to make a table of values, I want you to state the transformations, and then finally I want you to graph it. Now I'm going to help you with this first one because this is kind of complicated. So first, I want to look at just the parent function. In other words, if I get rid of all the transformations and stuff, I'm just looking at the function y equals 2 to the x, where a equals 1 because there's an invisible 1 times in front, and b is 2. B is always the thing raised to the x power. And why that's important is because then I can have my xy table. There's only 2 points I care about. It's 0a and 1ab. And in this case, a is 1, and a times b is going to be 2. So these are the 2 points I have. But now I got to do my reflections and shifts and stuff like that. So first, I notice the negative x here is going to be the y-axis reflection. And so I know what that means. In case you're wondering how that affects my table, a y-axis reflection is just going to make all my x values negative. So now it's -0, which doesn't matter, and -1. And the y values will still stay the same. So that's what a y-axis reflection does. An x-axis reflection would switch all the y values, so it'd be -1 and -2. So next, I don't see I have any scaling here, so I'm going to skip the scaling part and just go to the shift, which is +3. Remember, that means up 3. And what that means, going back to my table, I'm shifting all my y values up 3, or adding 3 to all my y values. So that means instead of 1 and 2, it's going to be 4 and 5. I added 3 to both of those. So there we go. I have all of my reflections taken care of. I have my coordinate points. This is great. And so now if I want to graph this, I know I have the coordinate points 0, 4, which let's just say that's this point right here. And then I have -1, 5, which let's say that's this point up here. I do know that my horizontal asymptote, which used to be at 0, got shifted up 3. So now my horizontal asymptote is right here at 3. And so then this is what my graph is going to look like. You'll notice the y-axis reflection flipped it this way, and this is perfectly fine for this one. So now I've got 2 more we're going to do today. I encourage you to try them on your own first, but they are difficult. Next I have y equals 1/2 times 4 to the x plus 1. And as a piece of advice, don't worry about the scaling. The scaling gets taken care of by the fact that a is 1/2 and b is 4. So go ahead, give this a try. I want the table, I want the reflections and transformations, and then I want you to try and graph it. So go ahead. Okay, so here's what you should have done. First, for the x and y table, I have the same 2 points every time. 0, 1, and 1/2 for a, and then a times b, 1/2 times 4, is going to be 2. So I have these 2 points to start out. Now for my transformations, I don't have any reflections because I don't have any negative signs. Again, the 1/2 was already taken care of because it's in my AB. In other words, the only time I have to worry about scaling is if it shows up in the exponent next to that x. But then I see the +1 here. The +1 is going to be a shift, and that's going to be a shift 1 to the left, and it's to the left because it's the opposite for the x values. So then that means I'm shifting my x values 1 to the left. That means -1 for my x values. So instead of 0 and 1, it's -1 and 0. And there we go. I've got all of my shifts and transformations taken care of. So then finally, plotting it, I have 0, 2, which I'll say is like here. And then I have the point -1, 1/2, which 1/2 very close to the 0 line, probably about here. Now my horizontal asymptote, again, starts at 0, but did it get shifted up or down? Nope, didn't get shifted up or down. So the horizontal asymptote stays at 0, as you can see here. So then my final graph should look something like this. And there we go, there's our graph. Now one more for us today. This will be the hardest one. Y equals -6 to the 2 minus x power plus 1. Now this one's probably too hard to do on your own, so just as a piece of advice, the exponent is the reason why this one's too hard. First, I would write the negative x first, so it's really -6 to the negative x plus 2 plus 1. And then I would factor out the negative sign out of the exponent, which means I really have this, negative x minus 2 in parentheses. And yes, you have to do that if you want to do this correctly. So from here, I think you can get it right without me. So go ahead, give this a try, and unpause the video when you're ready to see the solutions. Okay, so first, we can say that a equals -1 because the -1's out in front. There's an invisible 1 there. And b is going to be 6. Keep in mind, if you say a is -1, you're already taking account for the x-axis reflection. So I'm not going to worry about the x-axis reflection later on. I've got it right there. So then making my xy table, the point 0, 1, the y values will be -1 and -1 times 6, so -6. And now the transformations. So we already got taken care of the x-axis reflection. We also have a y-axis reflection. So for the y-axis reflection, I need to flip my x values and make them negative. So it's -0 and -1. But like we said, -0 is still 0, and -1, sure, that's okay. Now, if you didn't cover the x-axis reflection yet, and you had +1 and +6, you would certainly switch it now, and then it would be -1 and -6. But again, I didn't have to worry about that, because I already got that when I said a equals -1. Finally, the shift. Looks like the shift is -2, which is really 2 to the right, and +1, which is 1 up. So I have to go 2 right and 1 up. That means my x values are going up by 2. So instead of 0 and -1, it's 2 and -1. And for my y-axis shift, it's up 1. So add 1 to both of these y values. So it's going to be 0 for the first one and -5 for the second one. And again, you have to do the shifts last. If you don't do the shift last, you will get the wrong answer. So then finally, I'm going to plot this. I have the points 2, 0 and -1, -5. So let's say that's something like this. So 2, 0 and -1, -5. And finally, my horizontal asymptote. Where should that go? Normally it's at 0, but as we can see, it got shifted up 1. So now my asymptote is at +1. So that would look something like this. And connecting my dots, I get a graph that looks like that. And there's our answer. So that last one was tough. If you want to watch the explanation again, I encourage you to. Thank you all for watching. I hope you have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.